review. And in our review, we're going to discuss how to stack up lab. We're going to go over that information, and you should be able to fix what it is that you got incorrect on your lab. Make sure you fix any areas that was marked wrong. That's with an X on it. Putting it in a different color so when you're looking back on it and you're studying, you know what it is that is correct. So let's go through this. You had your 4 outcrops that look like this. Can I please get a volunteer to put these together? When I say put them together, what we're going to do first is we're not going to layer them just yet. We're just going to kind of put an outline of what the world looked like. So I'll start it off by saying, remember how we looked at those two and we saw that they matched, correct? And that's how we're going to just layer them going across the board so that we can have a pretty good picture of what's happening around the world before we stack it and make a geologic column. Francis, you had your hand up? Come on and do this for us. And this is the first thing that you all did before you were able to answer your questions. I'm going to stop for a second because that doesn't match. Oh. Don't finish. Stop with outcrop 2. You need to finish with outcrop 2. It was definitely the bottom of this layer, so it still has to be the bottom portion. And make sure you line those up. Okay, no, this is still part of this. Everyone see that? So what this is telling us about the world is, well, let's first say this. The geologist who was working in this part of the world over here, where outcrop 4 is, could have safely assumed what about that layer? It's the oldest layer. However, when other geologists from other parts of the world started to dig up rock layer and dig up rock layer from their areas, then it was saw that this is not the oldest rock layer. Instead, this is, correct? After we look at them, we can say, okay, when we're in this part of the world here, what happened with the world when we look at all of it is, first, this layer here was the rock layer that was placed about. And then we look throughout the rest of the world and we see that this area here, and this area here does not have this rock layer here. So what can we say about that area of the world in relative age in comparison with the other parts of the world? That part of the world is older because it has rock layer. The other parts of the world did not have rock layer. So we can safely say that the entire world is probably, every part of the world is not the same age. They did not form into existence until later on in the world, right? Okay, so over time, we had this rock layer being placed in the world. Then we had this rock layer being placed in the world, and somewhere along that time, same rock layer was placed. Then as time moved on, then we had this orange rock layer with the X fossils. Time continued to move on, and then we had, let me fix this just a little bit better. Time continued to move on. We then had the blue rock layer with the X and diamond fossils. Time moved on. We had the green rock layer with the triangle fossils. But if we look here, what happened in this part of the world here? It's missing. What's missing? The green layer is missing. It's not here. What is the name of that layer? If you look at the front of your paper, what was the name of that layer? Remember, this is outcrop 3, this is outcrop 4, this is 2, and this is 1. Is that the light shell? Is it really? It's the dark shell. This is your dark shell here. The dark shell is missing. So what probably was going on in that part of the world? Ice age. So there's non-deposition. What else happened there? Erosion. What was eroded? Part of the blue with the X and triangle fossils. Do you understand how all of this went on? Which outcrop represents the youngest part of the world? Not rock layer. Which outcrop? Outcrop 1. That had the oldest layer. Outcrop what? Outcrop 3. 3 or 4, because 4 is able to go to the youngest rock layer. So is 3. But 3 started older, so definitely 4. Okay? Any questions about that? Did everyone understand that these shapes that are within the layers, these are considered fossils? These dots are not fossils. They're what? They're part of the rock layer. They're not the fossils. The fossils were the shapes, the swirlies and the triangles and the diamonds and all of that stuff. Any questions about that? Okay, so then let's go on to the questions that you all had to answer. You ended up with a geologic column that looked like this once you stack them together. In stacking them together, raise your hand. How many layers did you have? 12. Not 13, not 15, not 11. If you had 11, that means you overlaid something and you kind of missed something. I did great on you properly stacking your layers. Doing the lab and putting your layers together, that was 50 points alone. So you lost some points on not stacking them correctly. All right. Which layer, or which is the oldest layer in your column? And you had to describe it either in terms of rock layer and or fossils. Aaliyah. Come up here and circle which one is the oldest. Okay, so that's the oldest rock layer. Good. Does anyone disagree? Put it there. Don't turn it on. I'll bring it over. All right, so our oldest rock layer, what was the name of that rock layer? Conglomerate. That was the conglomerate rock layer. You could have either described it as the conglomerate, described it as the color that you colored it, or described it in terms of the fossils that it contained. Which fossils are in that layer? X's and rectangles. Which rock layer is the youngest rock layer? And some of you came to me and said, I don't know the name of that layer. Come on up and circle it. Circle in a different color, in green. She's going to circle the youngest in green. And for you to describe it, you either described it by the color of whatever color you colored it, or the fossils. It's the rock layer with just the circles. Any questions? Okay, very good. How do you know which is the oldest and the youngest layer, Kaylee? She She says the oldest is on the bottom and the youngest is on the top. I did take that, but what tells you that? Sharon. The law of superposition. That was the more sophisticated answer, the law of superposition. All right, here we had to list the relative age of fossils from oldest to youngest. So we had to use our knowledge of the law of superposition to list our fossils. Based on what we know about where the rock layers are, our oldest rock fossil should be where our oldest rock is. Who wants to come up and give it a shot on listing our fossils by age, oldest to a youngest? Eliza has her hand up. It went up. Yep, you're going to list them using the shapes, and you're going to list them starting here on this line there, going to the youngest there.
So just
Write the shapes. So let me say this for a second. Some of you were listing them, you labeled these A through H, A through Z or whatever, and you start giving me letters. And I'm like, I said fossils. Some of you started talking about the colors of the rock layer, and again, it says fossils. So your fossils are the what? The shapes. You can just draw the shapes. You didn't have to write the names of them. Stop 1 second. What's that first shape?
it's like just,
Where'd you get that from?
it's just lines.
That's not a shape in there. That's actually part of the rock. Okay, stop right now for a second. Do we need to put multiple fossils? No, if we put it once, it's represented for them all. Go, let me stop for a second. What you're going, let me step down for a second. You're just going to list the first fossil, the next one, the next one, the next one, going in an order. Let me lock this. Okay. Eliza, do we need to write the X again?
That's the next layer.
But do we need to write it again?
No.
Because if that organ,
Oh, I
that's
see
just
what
saying that organism continued living, there was more in each layer. It continued living, and then at one point it became extinct. Wherever you don't see the, go ahead and erase it. Wherever you don't see that fossil anymore, meaning the layer before it, that's where it became extinct. Okay,
Yeah.
again. Okay, let's check and see if this is correct. At the bottom layer, what fossils do we have? X and rectangle. What came first? The X or the rectangle? The rectangle, because it doesn't exist anymore. So should the X or the rectangle be first? Definitely the rectangle. Then as we start to look, we then have what fossil? An X. And the X continued to live throughout this layer, and throughout this layer. But what other organism appeared? The diamond organism, which left diamond fossils. At that point, the X fossils were extinct because they don't show up again. At that point, what else was extinct? Diamonds, because they don't show up again. Yes, it does. I'm sorry. It does show up right here. I apologize. The X was extinct, but the next layer contains what fossils? Triangle and diamond. So the diamond organism continued to live, but now we start to see that organism leaving that fossil. After this layer, what becomes extinct? The diamonds then become extinct. But the triangles continue living. The triangles continue living, but what pops up? Swirlies. After that layer, what is extinct? The swirlies are extinct, but the diamonds continue to live. The triangles, The triangles continue to live. The triangles continue to live, but what pops up? Squares pop up. Squares continue to live, but what other organism pops up? Circles. What becomes extinct after this layer? Squares become extinct after this layer. Triangles became extinct here. But what continues to live on? Circles. So, that is your proper order of fossils. Rectangle, X, diamond, triangle, swirly, square, and circle. Rectangle's first because it actually is the first, it's the oldest one because it's not existing anywhere else. Okay? Got it? When I say got it, that means you understand it. Okay. I'm going to start to move because where is this information located? On the website. And if I just went through it with you, you should be able to do it again on your own. Alrighty. When we look at the unconformity in outcrop 2, the unconformity in outcrop 2 would be located here. Which layers are partially or completely missing? Dwayne? Okay, so you have to look between this outcrop and this outcrop. If you take a look, okay, we know that 3 doesn't have this one, it doesn't have this one, but 3 has that one. 3 has this one. Does outcrop 2 have this one? No, so which one's missing? The dark shell. Outcrop 3 and 2 both have this one. And if we go back to our table display here, we see this is outcrop 2, this is outcrop 3. We see that the dark shade is missing. What else is partially missing? Some of the blue with the diamond and X fossils. How do we know that that was missing? How do we know what was missing and what was partially missing? What did we just do? We looked at them both. What is that doing? We compared the outcrops. And that's what they do as geologists. They compare pieces of their stratigraphic pieces from parts of the world to see what is it that they do not have, like a puzzle. Okay? Everyone got it? Can I move? All right. Which, if any, fossils can be used as index fossils for a single layer? What, Josh? What can be used as index fossils? Well, time to get it now. What is an index fossil? Janae, help them out. What's an index fossil? So it's located where? Not only at the bottom. It's only located in one layer, and that's what we just answered here. Fossil located in only one layer. How do you remember that? Index finger. What finger is that? One layer. All right, Josh, now that you have that information, which, if any, fossils can be used as index fossils? Which of your fossils, when you look at it, are only located in one layer? Josh, louder. The X actually is located in the brown layer, the yellow layer, the blue layer. So it's not only in one layer. We'll look through your layers. Put your hands down. Look through your layers, and which fossil is only in one layer of rock? Josh, listen to what I'm saying. Everyone be quiet. Each layer is a different color. Look for a fossil that is only in one color. Your circle is in the red, it's in the top one. Which fossil? Come up here so you can look closer up here. Come up here. Really closely at all of these shapes. Which shape is only located in one color, where you only see it one time in one color, and you don't see it anymore in any other color? The rectangle is one, yes. What else? Josh. The swirly spirals. Good. Got it now? All right. So the rectangles and the swirls. Some of you just put one, and I put and. The rectangle is located here, and the swirlies are located just in that layer. Why are they index fossils? Because they're located only in one layer. What method would be required to determine the absolute age of these fossils, Michael? Radiometric dating. Some of you said absolute dating, and that is not correct. It's radiometric dating. What would they do? And this is not a question on here. What would they do with those fossils to get the absolute age? What would they do with that fossil? We use something. We look for something. We use half-life, but what a half-life of what? Not just carbon, but a particular element. And we see how long would it have taken for us to get back to the original 100%. Any questions on this? Okay, then let's go ahead and put our mapping, or what was it, finding locations on Earth in front of you. That was your pink sheet, or it could be white if you print it offline, but it's called Finding Locations on Earth. It's a sheet we did prior to today. And basically this sheet goes over your longitude and your latitude. And this was a review from 6th grade year, and it just tells us that every location on Earth, cut it out, every place on Earth has a latitude and a longitudinal address. That means where the lines on the Earth, when you look at a globe, where they intersect. Every line has an intersection point. The parallel lines and the horizontal line, the parallel lines and the vertical lines all have an intersection. And every spot where they intersect is a location. Your house is on a latitude and a longitudinal line. And you got numbers that go there. And then we assign you, not we, but the city or the county assigns an address to that. That's registered to the city, registered to the county, registered to the state, registered to the world. So if someone from New York City is traveling by car, by bus, by plane, by boat, whatever, to get to your house or to your city, they would be able to locate you. So someone, let's say your relatives from New York are driving to come and visit you for the summer. They would put that in their GPS. Their GPS actually pulls up a long number that you see on here. And it pulls up that number, that satellite is gathering that information, and it registers as the address that you put in, and that's how it gets you exactly to the location. Now, sometimes it's not updated, especially when we newly built communities or we newly built restaurants. Then you can't find them, and you're like, this dang GPS doesn't work. It took me to the wrong spot. Well, it didn't have that information registered, or sometimes GPSs are outdated because it's not linking to the different satellites that are springing out of our Earth to pick up different areas and locations. Any questions about that? Is that pretty sophisticated? Did you know all of that was going on while you just punched that in your phone and it says, turn left, recalculating route? It's like, how does she know? She is a genius. My navigation actually does something so weird. When I leave out of Moss Creek, she sounds like this. Turn right on Harris Road. And then, as soon as I get past the race car driver's house, she says, make a left on Odell. I'm like, whoa! Like she get all weird on me there. All right, so let's then move through. Then again, just review from 6th grade. I'm not going to go over every little point on your paper there. I'm just going to kind of review this with you. We do know that our Earth is round, and our Earth being round, we have an equator. An equator chops our Earth directly in separating the top portion being where Santa lives and where I want to live. All right, so we have those two halves being chopped by the equator. Our North Pole is 90 degrees north latitude, and our South Pole is 90 degrees south latitude. And we have all of these different areas on our Earth that helps pinpoint. Now, not only is that good for us, because when we're driving along to get to where we want to go, is that the only way that you can travel? No. How else can you travel? You can fly. Now, when the pilot gets in the plane and you're flying from here to, let's say, where do you want to go? France, I heard. You want to go to France. Is there, when the pilot gets in, does he put in his navigation, all right, take me to 123 Air Street, France? He has to put in coordinates, which is your latitude and your longitudinal intersect, so that he gets you directly where you want to go. Do we need to have reliable satellites in the world so that if you're flying to France, you don't get to Japan? Yes. You don't want to get off and like, whoa, wait, this is not where I need it to be. Okay. How else can you travel? You can travel by train. They have to do the same thing. Wow. Boat. Is there a address when you get on the cruise ship and the maitre d' puts in his information? Does he put in 3, 4, 5 water place? No. He has to put in coordinates so that you get you to the correct island. If you're going to the Bahamas, you don't want to end up in Antarctica. They do have to know the coordinates. That's why that is a science and a geography thing that they have to study, because they have to look at a map and know what the coordinates are on the map so they can properly travel and navigate through the water. Everywhere. All right. Then we talked about the prime meridian. The prime meridian is something like the equator, but unlike the equator, it doesn't cut the Earth in half like the equator does. You have a eastern line and you have a western line, which is on both sides of the Earth. So that is that. On your paper, you had the Earth where I opened it up for you and kind of just laid it flat on there for you. What I want you to do at this time is we want to label the northern, southern, eastern, and western hemisphere. Where's your northern hemisphere? Top, bottom, left, right. It's on the top. So you want to go ahead and make sure you label this as the northern hemisphere or the North Pole. What is this? This is your eastern hemisphere. Down here, there's no East Pole. Down here would be southern hemisphere or South Pole. Oh, wait, here's Santa. That's Santa. And then he has a bag of toys. And then there's a reindeer. There's a reindeer. And then we got a snowman. He lost weight. He lost weight. All right. And then what is this? This is your western hemisphere. Again, never eat soggy waffles or never eat shredded wheat unless you put sugar on them and some strawberries and blueberries in it and to make it taste really good. All right. If we are at 40 degrees north and 100 degrees east, where would we be located? China. We would be in Asia, continent. We don't really know if we're in China. So what we would do is we would take the 40 degrees north and we would stop at 100 degrees east. Is that right? Is that right? Yeah? Okay. We're in the eastern part, and we're at 40 degrees north. We're in Asia. Okay? Now, if you are in South America, which is here, what places are in South America? Brazil. Argentina. All right. What would be your possible coordinates, your latitude and longitude? Carter.
20 degrees south, 60 degrees west.
20 degrees south. My map, I can't see the bottom of my map. He says 20 degrees south. Is this 20 degrees south? This is 20 degrees south. Okay. 20 degrees south and 60 degrees west would put us dead smack in the middle of South America, where we're chilling on the beach. I'm chilling on the beach still, but then I'm gonna go to the water later, a couple hours, but whatever. All right. It's in the swimming pool in the back of the hotel, duh. It's called the Beach Hotel. Duh. All right. And then you had this information. We're going to go through and get the information from here. What process is used to collect information about objects without being in physical contact with them? Starting with Seth. Remote sensing. How do you remember that? Remote means what? No, remote does not mean control. You have a remote control that does what? It controls how? How? Do you have to get up to the TV, have the remote, and still press the button? You control it from where? From a? Which means from a? Distance. Thank you very much, Ashley. It's like pulling out all of their teeth. All right. Remote then obviously means from a distance. You do not have to be there to do it. Therefore, sensing also means to feel or to pick up information, to gather information. So remote sensing means gather information from a distance. There you go. Thank you for telling me. Can you? Yes. All right. What do the initials KJ GPS stand for? Global Positioning System. She only has to go to the bathroom because I was being really funny. I'm a comedian. Or if you ask a 6-year-old, a 6-year-old probably would say getting people somewhere. All right. What can the Global Positioning System help you to do, Allison? Which one did I skip?
There's like two. There's two.
I'm sorry, I don't think I put them on here. This was the old one. Okay, my apologies. We have GPS. What does that stand for? Global Positioning System. Then your next question on your paper says, what type of signal is continuously beamed from satellites to GPS ground signals, and it records the exact distance between the satellite and the ground, and these signals are used by GPS to send information to Earth. This is how we get where we need to go. Those are radio signals. Very good. And now, Tim, what can the GPS help us to do?
Find your location on Earth.
It can help us find location on Earth. If you put get directions, get places, that's perfectly fine. The next one, list 3 things that GPS system can tell you about a given location on the Earth. Sham, give me one. Longitude. Ashley. Latitude. Elevation. So it tells us the length, height, and then even if something is in a mountain, how tall. Yes. That would still be falling under latitude and longitude because remember, every place has a coordinate. This is good for campers, especially for elevation. You would like to know how high you are on the Earth. All right, over here. Map makers. JD, you use GPS for what?
Verify location of boundary lines between countries and states.
Verify locations of boundary lines. So verify boundaries. If you had a map and you were going somewhere and they didn't use the GPS to put it there, it is possible that you're driving from here to South Carolina, but you actually end up in Virginia. They totally messed up. So we need them to do that correct thing, correct? Tamia, what do air pilots and sailors use GPS for? Navigation. Good. Business and state agencies use GPS for what, Michael? Mapping and planning, definitely. And how many of these are number 6, 7, and 8 that are up here are something that maybe you may be interested in later in life, maybe making maps. Okay, that's fine. Becoming maybe an air pilot or a maitre d', controlling a boat, or maybe even a flight attendant. Okay. A business or state agency or owner. How many of you want to be a business owner? How many of you want to build your own business? How many of you would like to be a part of building your own house? If you are a business owner or building your own business, even if you're just the owner, let's say you find a location like, oh, this will be a perfect spot for a shopping mall that I want to build there, or a boutique that I want to have there. Then you have to know the coordinates. When you pull out your mapping plans, you have to be able to look at that and say, okay, I'm going to be taking up this much space in this much area. That's information that goes into that, and I wish you all luck for that. But if those do not appeal to you, how many of you want to be drivers? That's probably all of your hands. You want to drive, don't you? I don't mean drivers like driving a truck. I mean getting in your car and going to your friend's house. All of you. But if you don't keep good grades, then you will not be drivers. But what does a driver of a car use GPS for? Colin. Yes, so what would you use GPS for if you were a driver? Don't give me those words. What would you use it for? Directions. Exactly. Any questions? Okay. They've now sophisticated the GPS, and the satellites can even pick up traffic. So it can tell you, there's traffic here, don't go that way. There's construction there, so we want to reroute that route. All right, moving on to Ayana. What does GIS stand for? Geographic Information System. And the GIS allows the user to select different types of what, Danica? Information about an area from a single database. Information that we're talking about is things like mountainous plains, land, water, stuff like that. It gives us that information because they are, as number 12 tells us, Shailene, each piece of information on the GIS system sits on a layer. So when we looked at the map yesterday, we saw that when it was working correctly, we saw that at first we can look at it from just highway standpoint. And then we go deeper, we'll start to see actual roads. And then we go deeper, we start to see trees and houses. And we go deeper, we actually start to see neighborhoods. Those are layers, okay? And depending on what you're using the GPS for will depend on which layer. If I'm just going from here to Darius' basketball game on Saturday, which is at Ray's Splash Planet, and Francis have made me scared to death now to go there, then I'm going to use, and if I don't know my way, if I just need to get to downtown Charlotte, I'm going to use GPS, and it's going to be on the neighborhood perspective. But if I need to drive from here to Florida, then I'm going to get on the highway layer. But we don't need to do anything special for that. Our navigation GPS system automatically does that for us. All right? Moving on to number 13. Each layer in a GIS, it can be turned on and off to help users access the information also they need, which is what we just did. All right, Ryan, what is the land satellite deployed to carry remote sensing equipment? What is that called?
Radar.
Say it louder. Right here, I'm pointing to it. Landsat. It's called a land satellite, and it's a Landsat. That's exactly what it is. It's probably the easiest thing that you would ever remember. And Landsat data, they're useful for thematic mapping. What is thematic? What word do you hear in thematic? Theme. So what do you think a thematic mapping is? A map with a theme. Give me an example of a map with a theme. Raise your hand, Francis.
A map of Charlotte, a theme of Charlotte.
So that would be a city map. Okay, that's a theme. That's a city map. Good. Give me another one.
Map of space.
Okay, space map. Good. Good. An amusement park map. That's good. What about what you all look at in the morning to see what you're going to wear? Some of you. Map. What type of map do you guys rely on to see what you're going to put on in the morning?
Oh,
The weather map. There are other maps of the world. There's terrain maps, which looks at the land like mountains and grass and trees and stuff like that. Then you have state maps, like where it helps you travel state to state. City maps, which helps you travel within the city. You may have a school map, which helps you navigate through the school. So there's various different types of maps. Make sure you have an example down there. a mall map, which is probably my favorite type of map. Any questions? Okay, so now that we have that information, the next thing that you did was trying to write the directions from here to your home. How many of you wrote directions that was very, very, very identical to what your navigation in your phone gave you? Good. How many of you wrote directions but you had no idea where you were going? If I listened to your directions, I would be lost. How many of you do not know the names of the streets that surround you? You knowing your address and you getting home from here is not good. If you cannot tell someone how to get you home, then you, when you're riding the bus today, you need to be looking at these different streets, because if anything were to happen, God forbid anything ever happens, you need to know how to get home. Also, pretty soon, most of you will have your license and you will be driving. Now you say, well, I know a street to turn up, but if you ever got lost or your car breaks down, you need to be able to let someone know where you are. It's very important to know your surrounding areas, especially the locations and where you drive on a daily basis. A lot of you hang out with people in this neighborhood. You need to know how to navigate yourself at least from the school to this neighborhood, because if you're hanging out in this neighborhood, it can become very tricky when you're somewhere and you're lost. You need to know how to at least get back to the school. And then from the school, if you couldn't get home, if no one could come and get you, you need to at least know how to get home or tell somebody how to get you home. So when you're leaving school today, your phone's dead, your battery's dead. When you're leaving school today, I'm trying to help you out. I mean, if you don't want to, that's fine with you, but I bet you I'm going to know how to take care of myself. So, right, okay. So, when you're leaving school today, I would highly, highly suggest that you just kind of pay attention to the streets. Instead of sitting there chapping and talking with your friends, just kind of pay attention to the street signs, because you never know when that may come in handy and when you may actually need it, and at least you will have that. You understand? Because again, in this class, I don't just teach science, I teach you. Thank you very much. All right, so from there, we had that information and we moved on from there. So now I want you to put, I'm sorry, I didn't pass out my next sheet. You're going to get a sheet that looks like this. You're going to have two sheets. I'm sorry, one sheet, but it's front and back. And pass it around. You're going to use this to review for geology. You may work with your row, your table, but what I want to suggest to you, if everyone look up here for a moment, is when you're working on it, try to work at it alone for a moment. I am not collecting this from you. This is going to be for review, and then tomorrow we're going to review some more for your test. So don't look for your partners and say, what'd you get for this? What's the answer for this? See what you can do without your notes. And then if you get stumped, use your notes. And then if you're still stumped, then talk to your partners, but don't talk to them and say, what did you get for this? What's the answer? See if they can explain it to you, or if you can explain it to them. Put your chair down, Michael. And that way, that will help you in studying and reviewing, because as you can see, your homework only says Greek and Latin. Am I telling you to study for this test? Which would help you to assume what? That we're going to study in class and you don't need to study outside of class, which means the test is presumably what? Easy and short, if you pay attention and do what it is that you're doing in class. Now, after tomorrow's review, if you're still stuck on some things or you're having trouble after tomorrow, then I would require for you to go home and review some information. So do this the appropriate way, the front and back, and working at it so that you get some good studying on. Okay? Any questions? Okay.